The first step in determining the molecular formula for a compound from masses of the components is to start with figuring out the empirical formula. So just like we did with the previous example, we're going to figure out how many moles we have of boron and how many moles we have of hydrogen. So I want to look up the molar mass for each of these compounds because the molar mass tells us the mass for 1 mole. So I'm looking up the molar mass for boron on my periodic table, and there are 10.811 grams of boron in every 1 mole of boron. But we don't have 10 grams, we have just 3.24 grams. And so we want to know how many moles that would be. So I've got here is 10.811x equals 3.24. So x, the number of moles, is 0.2997 moles of boron. I'm going to do the same thing for hydrogen. In 1 mole of hydrogen, there are 1.0079 grams. So the grams in 1 mole. And we don't have 1 gram of hydrogen. We have a little less than a gram. We have 0.907 grams of hydrogen. And we want to know how many moles we have. So again, cross multiply 1.0079. X equals 0.907, and when I take both sides and divide by 1.0079, I get X is equal to 0.8998 moles of hydrogen. So just like I did in all the previous empirical formula problems, I'm going to compare those 2 moles. There are it's basically 0.3 moles of boron for 0.9 moles of hydrogen. And if I make that an improper fraction with whole numbers instead of decimals here, I've basically got 1 mole of boron for every 3 moles of hydrogen. And so my empirical formula, type that here, empirical formula, would be BH3. There are 3 hydrogens for every 1 boron, which would be the for every statement. But I want to figure out what the molecular formula is. If I just take 1 boron and 3 hydrogens and add them up, that would give me a molar mass of around 13 or 14. But it says that the molar mass of this compound is actually 27.7 grams for 1 mole. So I gotta say, I've got to come up with a factor that I can multiply both the implied 1 subscript for the boron and the 3 here, something I can multiply those both by to get a formula that has a molar mass of 27.7 grams. So I'm going to set up a little problem here. Boron's molar mass is 10.811, and there's 1 of those, so I'm just going to multiply that by X. X is the factor I want to multiply by. Plus 1 hydrogen is 1.0079, but there are 3 of them, so I'm multiplying it by 3 and then multiplying that by X, again the factor I want to increase my formula by, and that has to add up to 27.7. going to collect like terms here. So when I've added together all my x's, I get 13.84x equals 27.7. I'm going to divide both sides by 13.84. And x is equal to 2. So what is the 2? What the heck does that mean? That means instead of my empirical formula being a ratio of 1 boron to 3 hydrogens, that factor is what I have to it's like the opposite of reducing a fraction, like expand the fraction by. So I'm basically going to multiply each number, each subscript in my formula here, by 2. So my molecular formula would be B2H6. So that is how you figure out the molecular formula for a compound.